Today we're going to continue our stoichiometry and introduce the concept of limiting reactants. So what we want to be able to do, much like the stoichiometry, is be able to calculate the quantity of the product here based on what we're initially given. So limiting reactants are essentially the reactant that gets completely used up in the reaction. So up to this point, we've always assumed that at least for one reactant, we had plenty of it. In reality, we really don't. Right? We have a fixed amount of the reactants or the ingredients that we're going to have available to us. So eventually, one will have to run out. They're not going to be used at an even rate. Much like if you were baking something, you may use up all your eggs first just because you have less eggs than anything else, so the amount of brownies you can make is pretty much limited. So the way that limiting reactants work is that there's just not enough of each reactant. So the reaction is going to happen, both reactants are going to react to make the products. Eventually one of them will run out, if not both of them. So once the reaction stops, that means one of the reactants at least has run out or has been completely consumed. If there are any remaining reactants, we consider those the excess or the leftover because they're not all used up, there's still some remaining. And of course, the amount of product we can make is determined by the limiting reactant. Clearly, if we run out of one of the reactants or one of the ingredients, we can't make any more product. So identifying the limiting reactant is pretty easy. All you have to do is just find the reactant that will make you the least amount of product. So now we're going to be given initial quantities for every reactant. We just have to first figure out which one is going to make me the least amount of product. When the product formation is limited, that's how we know that this reactant is the limiting one. So let's take a look at an example here in the production of water. So first off, we want to identify the limiting reactant if 4 grams of hydrogen reacts with 16 grams of oxygen to produce water. On first glance, you're probably saying, okay, 4 grams of hydrogen, 16 grams of oxygen, great. There's a lot less hydrogen than oxygen, so clearly hydrogen is the limiting reactant. But we can't compare grams for elements. Grams are very arbitrary, they don't actually tell you much information. What we can compare though are moles. And we have to figure out how many moles or how much product each one of these reactants can make us before we actually make any decisions. So even though the 4 grams of hydrogen here are clearly less than the 16 grams of oxygen, we have to first check that hydrogen is actually making less product. So first off, we want to write our reaction. So our classic water reaction, 2 hydrogens plus an oxygen produces 2 waters. Okay, so we've got our 4 grams of hydrogen and our 16 grams of oxygen. And we want to figure out how much water they can make. We don't have to go all the way to 4 grams for this. Moles is sufficient, since the number of moles would basically figure out how which one makes the least amount of grams anyway. So let's just figure out how many moles of water we're going to make. So 4 grams of hydrogen. To figure out how many moles of water, we're going to need moles of hydrogen. So we've got to convert these 4 grams into moles. So just for number's sake, I'm just going to round the mass of hydrogen a little bit to 2 grams. So 4 grams of hydrogen can make me 2 moles, has 2 moles of hydrogen present, times a 2/2 ratio of hydrogen of water to hydrogen, means that we can make 2 moles of water. So let's do the exact same thing here for oxygen. 16 grams of oxygen. Let's put a G here. If oxygen, because diatomic, has a mass of 32 grams, 16 grams of oxygen is actually 0.5 moles of oxygen. So you can already see here, we have significantly less moles of oxygen. Even though we had more grams of it, the actual quantity of oxygen is a lot less. Times, well, we want water, and it's a 2-to-1 ratio between water and oxygen. So we can only make 1 mole of water. So my 4 grams of hydrogen can produce 2 moles of water, while 16 grams of oxygen can only make 1 mole of water. Clearly 1 is less than 2, so oxygen here is my limiting. because I'm limited to just 1 mole of water. I cannot make any more than this 1 mole because I have to run out of oxygen. So now we want to calculate the mass of water that can be produced. Well, we just figured out we can't make more than 1 mole of water. It's impossible to make 2 moles because of the fact that I have no more oxygen left. So if I have to figure out the mass of water that can be produced, I need to know how many moles of water I can make. I can only make 1 mole. So my product quantity is solely dependent on the limiting reactant. So since I can only make 1 mole of water, the mass of water I can make is only based off that 1 mole. So just taking this times the molar mass of water, I can make 18.02 grams of water, and that's it. Once I make these 18 grams of water, I run out of oxygen, my reaction's done. So for the limiting reactant, you have to just figure out how many moles of the product do you make the least amount of based on your initial reactants. Again, you cannot go based off the grams, you have to figure out moles. And then from there, taking the lesser quantity, you can figure out the mass of the product.